was loud this time. All right, so we stopped on page 11, right? What? You can. That's how it works when I have a camera here. Oh, I don't know why. Maybe they cleaned it. I guess so. Okay, we stopped on page 11, right? Should I go back over page 10? Great, we'll start doing that. Oh crud, there's a chair there. We're gonna move that out of the way. We're also gonna mute everyone. Dang it, there it is, mute all. So the plan today is I'm gonna go over the first example. Then the second one, y'all are gonna do on your own, and I'm gonna go over a homework problem. And then whatever else we have time for. Okay. Then going back to the bottom of page 10. We were defining how to find the critical values using the standard normal table. So let's do the first one. It's for a left-tailed test. So what does that mean? It means the alternative hypothesis has a less than sign in it. And in this case, we find the critical value by this. Draw the Z curve. This is a left-tailed test. We're looking at the area to the left of some unknown Z score. What do I call it here? Minus Z alpha. The area to the left of this is going to be equal to alpha. So all you need to find is a Z score such that the probability of Z being less than or equal to minus Z alpha is equal to alpha. Everyone remember that? That's why I use the subscript here of alpha, because the area to the left is alpha. The next one doing the same idea, but switching it to the right-hand side. So for a right-tailed, the alternative looks like this. Mu is greater than the hypothesized mean. And then again, you have the distribution of the Z scores. And in this right-hand tail here, the area to the left of that, or not the left, the right of that is equal to alpha, and you call this positive Z alpha, or you can call it Z of 1 minus alpha, because the area to the left of this would be 1 minus alpha. Then all you need to find is a Z score such that the probability of Z being less than or equal to Z alpha or Z 1 minus alpha, doesn't matter how you call it, is equal to 1 minus alpha. Can everyone see why that is? Because the area to the right is alpha, the area to the left is 1 minus alpha. So therefore, since the Z score table only gives you the left-hand area, you just look at this left-hand area here and find the associated Z score. So on your exam, there was both of these cases came up. And the last one is two-tailed. And the alternative hypothesis looks like mu does not equal the hypothesized mean. And in this case, you have two tails, so the rejection region is going to be in two tails, or two areas. And the area to the corresponding upper critical value, the area to the right is Z or alpha over 2. And the area to the left of the negative critical value is again Z alpha over 2. And the easiest way to find the critical value is to find the negative ones. then all you do is the probability of z being less than or equal to minus z alpha over 2 is equal to alpha over 2. And you find that associated z-score in the table. Then if this is the negative, then obviously the positive one, just take the negative off. If I wanted you to find the upper one, how would you do that? To find the upper one, the probability of z being less than or equal to the positive z alpha over 2 is equal to what probability? The area to the right of this z alpha over 2 is what? Alpha over 2. So the area to the left is what? 1 minus alpha over 2. That's how you'd find the upper one. Anyone remember that? That's what we went over last time, very end. Then there's a little table. I really don't want to draw this table, so I'm just going to show you it. So here's kind of a summary chart of the z-test for the means using the different methods. So in this case, we're only looking at, I guess we haven't done that method yet. Yes, z-test. On your homework, it will say, find the test value. What that just means is find z-test or t-test, depending on whether you know sigma or not. Then using these 3 different types of tests and the corresponding rejection regions we have for a right-tailed test. So where is it? This one right here. You reject a null hypothesis if you get a critical value that falls within this upper region here. So anything that is greater than z alpha, that's represented here. So any z-score greater than this one right here will give you a rejection. If you're doing the p-value approach for the same thing, I think we call it the decision rule is always the same for a p-value approach. Reject the null hypothesis if the p-value is less than or equal to alpha. So that just means that the area corresponding to the right of our test value is less than or equal to alpha. Then using the same idea for a left-tailed test, just flips around. So the critical region goes to the left-hand side here, and then we reject the null hypothesis for any test value that's less than this negative critical value here. And the same thing applies here. So the p-value is going to lie just to the left because the alternative is less than. And then we reject the null hypothesis if the p-value is less than or equal to alpha. And then the final one, you have 2 rejection regions here. And you reject the null hypothesis if it falls into the left-hand region here or the right-hand region up there. The way I wrote it here is reject null hypothesis if the absolute value of your z-test statistic is greater than the positive critical value. I explained why that works, right? So if something, let's turn the camera back over here so they can see online. So if something is down here, right, that means it's less than negative z alpha over 2. So that means it's more negative than this one. When I take the negative off, then it's going to become more positive than this one. Does that make sense why that is? Or do I need to explain using an example? Cool. Then the p-value thing is still the same. I'll talk to you about how to find the p-value for a 2-tailed test in a little bit. It's a little bit more complicated than for a 1-tailed. Now, you want me to do example 1 or 2? I will read it. I missed the bottom. Oops. Which part? That was up here on the board? Oh, the chart. Let me turn it around. There you go. It was just the z-test statistic formula. So I guess I'll write that up here because we're going to use it in a second. So the z-test statistic formula is found by the sample mean minus the hypothesized mean divided by the corresponding standard error. Am I good to go now? Bailey, I think was the name. Yep. Cool. Okay, do I do example 1 or 2? Y'all pick. Cool, we'll go with number 1. Then y'all together are going to do number 2, and I'll walk around and help you. And then we'll go over our homework problem. I'll be nice during these 2 chapters because they're the hardest. The next one's the hardest. Okay, need to turn the camera around. There we go. We're looking at example 1. I'm not going to write the whole thing out. It says a consumer advocacy group claims that a local supermarket's 10-ounce packages of cheese actually weigh less than 10 ounces. Their group took a random sample of 20 such packages and found the mean weight was 9.955 ounces. The population follows a normal distribution with standard deviation of 0.15 ounces. That alpha is 0.05. Is there significant evidence to support the claim? Then the first part, state the null and the alternative. Part 1. What's the null? Yeah, mu equals 10. And what's the alternative? Yeah, they claim they weigh less than 10 ounces. I don't have this on the completed version, but what is the claim? Close. So they're claiming that they actually weigh less than 10, right? So this is the claim. So on your homework, it'll have you select which is the claim and which is not. The majority of the time, the claim will be the alternative, but not every time. Then what type of tailed test is this? Left, right, or 2? Left tailed test. Then part 2. Find the critical values and state your decision rule. Since it's a left-tailed test, just use page 4, and it says reject the null hypothesis if you get a z-test less than negative z alpha. So reject null hypothesis if the z-test statistic you compute is less than negative z alpha. And you want to find this. Do that. Just draw the distribution of the z-scores here. And since it's a left-tailed test, you're looking at the area to the left of some unknown z-score. So we're going to say it's right here. This will be negative z alpha. And the area to the left of that is what? Yeah, alpha 0.05. Then all you want to do is look up for a z-score such that the probability of z being less than or equal to negative z alpha is equal to 0.05. Now this one here is what your homework is very picky on. This is the one I actually put on your exam that I could say you could use the one that's below or above, because one of them is like 0.0005 off on the z table. So I think it's the one it uses. Where's my tables? Is it 0.4945? Something like that. It's just like negative 1.65, and the other one is negative 1.64. Okay, here we are. Negative 1.65 is what it should be. Okay. So that's why it uses it. The closest one in your table that doesn't go over this is negative z alpha is negative 1.65. And that corresponding area to the left of this is 0.0495. So this is the closest to that without going over, so use this. And that's your critical value. So then all you do is replace that critical value in here. So you'd reject the null hypothesis if your z-test statistic is less than negative 1.65. That's just plugging in what the critical value is. This is in the table. So on the, let me show you on the document. It'll be inside here. So just look in the middle here. So the closest to going with to 0.05 without going over is negative 1.65. So 0.0495. Everyone okay with that? So we've done part 1 and 2. Now let's go to 3. Compute the test value and the corresponding p-value. So part 3. Something you can do at the very beginning of the problem is identify these pieces of it. So in this case, X bar is the sample weight. What is that? Oopsies, my bad. There you go. The sample mean was what? 9.955. The hypothesized mean is what? 10. The standard deviation is what? Yeah, 0.15. And n is what? Yeah. Then you have all the pieces you need to put into here. So just plug it in. Then z-test, I'll just write it all out, is equal to X bar minus mu naught over sigma over the square root of n. Then plugging in those numbers here, we have 9.955 minus 10 divided by 0.15. Make it more clear, 0.15 divided by the square root of 20. If you plug that in the calculator, what do you get? The 2 decimal places. Yep, correct. Negative 1.34. Then how do you find the p-value of that? The p-value by definition is the probability of getting a sample statistic more extreme than what you got in favor of the alternative. So the alternative in this case is what? Less than, right? So we're looking at what's the probability of getting a z-score less than this right here. How would you find that? Very simple. Just look up the z-score of that in the table. Then the p-value of this one is equal to the probability of getting a z-score less than or equal to z-test, which is equal to the probability of z being less than or equal to minus 1.34. Someone tell me what that area is. Yep, 0.0901. As the p-value. You'll need to know how to find those based on what this says here in the alternative. It will guaranteed show up on 2 of the exam questions. Is everyone okay with how I got those? Have I confused anyone yet? Great, we're on a roll. And part 4, reach a conclusion and make an interpretation. Then, what did your conclusion need to have? I'm trying to remember where we put it. Here it is. Statement regarding your decision about the null hypothesis. So that's the first part. So whether we reject or fail to reject. In this case, what do? Is 0.09 less than 0.05? No, it's greater than. So therefore, since the p-value, which is equal to 0.0901, is greater than alpha, which is 0.05. What's another way you could come to the same decision using the critical value in your test value? We're going to reject if we get a test value that falls within this region, right? So less than negative 1.65. Is negative 1.34 less than negative 1.65? No. So therefore you fail to reject, so you get the same decision. Then fail to reject the null hypothesis. What does that mean in terms of the problem? Thus, or you can say therefore either way. Thus, there is not sufficient evidence to conclude the packages of cheese what part goes next? Weigh less than what? Oops. Yeah, weigh less than 10 ounces. Oops, that should say weigh, not weight. Weigh less than 10 ounces. That's how you write a conclusion. So you say why you come to that decision, you say what it is, and then you interpret it in the context of the problem. If the p-value would have been less than alpha, then what would be the conclusion? Yeah, there is enough evidence. The only thing that would change in that is take the not out. There is sufficient evidence. Then y'all do number 2. Everyone online, y'all can do number 2 as well, and then I'll go over it. Gosh dang it. Forgot I put that in there. Now it went blurry again. No idea why. Nice ringtone. If you think you know the first part, raise your hand and I'll come tell you if you have it right or not. Yes. Boom, boom. Correct. Yep. 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 That's right. So what tailed test is it? Right. Oh, also, if you look in your schedule on Canvas that I uploaded, I apparently missed a date in there. So I forgot to put the 24th. So whoops. So I don't think we'll have to cram like 4 sections into one day. There is one part in chapter 9 that I think I can skip, so I'll have to see if I can, because we had 2 snow days. And also, it's the part that I hate the most. Has anyone else in here not gotten their second exam back? What's your name? What was it? Gotcha. Has anyone figured out the second part? Oh, there it is. Oh, and that was. Where is it? I have no idea where it is. Don't can't find it. Is that you? Okay. Yeah, I was like, what? What's up? Okay, so in this case, it's a right tail test, right? So the area to the right of some z-score is going to be alpha. So that means the area to the left of it will be what? Yeah, so 0.95. The easiest, or you can just think of it this way. This was the area to the right in this case. In the previous example, we had the area to the left was equal to this, right? Therefore, this critical value would just be the positive of the one from the last time. So 0.95 is on the left, yeah. Okay, I'll go over it now. It says in Pennsylvania, the average IQ score is 101.5. The variable is normally distributed with the population. Standard deviation of 15. A school superintendent claims that blah, 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 blah. Have a higher IQ than the average of 101.5. She selects a random sample of 30 students and finds the mean of their scores is 106.4. Let's identify X bar, mu naught, sigma, and n. What is X bar? Yeah, 106.4. What is mu naught? Yeah, the hypothesized mean of 101.5. What is sigma? 15. And what is n? Yes. And the first part, the null and the alternative. So obviously the null is mu is equal to mu naught, which is 101.5. What is the alternative? So she claims that they have a higher IQ than average, so mu is greater than 101.5 is the alternative. Step 2. In the previous one, we had, it was a left-tailed test with alpha as 0.05, so we said reject the null hypothesis if the z-test was less than negative 1.65, right? That's if we had a left-tailed test. So if you have a right-tailed test, since we still have the same value of alpha, all you need to do is make this positive. So in this case, it would be, let's write it this way, reject the null hypothesis if, in this case, if you divide it by a negative, this flips the sign, right? So why did I put if twice? If z-test is greater than 1.65. You want me to draw out why that is? Cool. So someone also mentioned you could have this one, reject the null hypothesis if p-value is less than or equal to alpha. So they will both give you the same decision, so you can use either one. And the third part, z-test. Just plug in X bar, mu naught, sigma, and n in there. So X bar was 106.4. Mu naught was 101.5. Sigma was 15. And n was 30. What does that give you to 2 decimal places? Yeah, 1.79. Then the next part says find the p-value. By definition, the p-value is the probability of getting a test statistic more extreme in the direction of the alternative. So the alternative is greater than, right? So that means the probability of getting a z-score greater than the one we got. So it's the probability of z being greater than 1.79, the area to the right of it. But your table only gives you the area to the left, so just take 1 minus the probability of z being less than or equal to 1.79. If you do that, what do you get? 1 minus 0. Is it 9633? And that equals 0.0367. So that's the p-value. Then you make the decision. Both of these approaches will get you the same thing. So reject the null hypothesis if the z-test is greater than the critical value of 1.65. 1.79 is greater than 1.65. Or you could use this, the p-value of 0.0367. 0.0367 is less than 0.05, which is alpha. Put that up here. then this will change. Since the p-value of 0.0367 is less than alpha, which is 0.05, then reject the null hypothesis, and we can say, thus there is sufficient evidence to conclude the average IQ of students in her district is higher than 101.5. So in general, when you write the conclusion, you're trying to prove the alternative, right? That means we want to write this in terms of the alternative in most cases. So we're saying there is sufficient evidence to support the alternative, and the alternative is that the average IQ in her district is greater than 101.5. Does that make sense to everyone? Okay.
So we're using 1 minus, so 1 minus 1.633.
Yes.
Because this is a right tail.
Yes, we had to right tail
The
test.
table will only give that.
Yes,
Okay.
correct. Should I go over the extra example? It's actually a homework question, I think. It was the one I was going to go over and then I forgot it's actually in the notes. The reason I put it in here is because it's a two-tailed test and the other was right and left. Then let's look at this extra example. Let's do the same thing we did in this one. Are there any questions over that example 1 or example 2 that we just went over? Is everyone somewhat getting the idea of what we're doing so far? Okay, cool. Then let's do this one. I'll leave that up there in case you need to actually write that. Now let's look at the extra example. It's in your notes, right? It's okay, cool. 10 years ago, the average acreage of farms in a certain geographic region was 65 acres. The standard deviation of the population was 7 acres. A recent study consisting of 20 farms showed the average was 64 acres per farm. Test the claim that alpha is 0.05 and then find the p-value. Now, let's first start by identifying each of these pieces. It says 10 years ago, the average acreage of farms in a region was 65 acres. So is that 65 going to be mu naught or x bar? It'll be mu naught. X bar will be the current acreage using sample data. It says a recent study consisting of 20 farms showed the average was 64 acres per farm. That means X bar in this case is 64. And N is how many farms they selected of 20. And it says the population standard deviation was 7 acres, so sigma is 7. Test the claim that alpha is 0.05, that the average has changed by finding the p-value. That means alpha is 0.05. Now we need to identify the null and the alternative. What is the null? Yeah, mu equals 65. So when you write the null and the alternative, make sure you include which parameter you're talking about. So sometimes I'll just get students that put equals 65 on the exam. What equals 65? I need to know which parameter you're talking about, whether it's mu or p. And in the next chapter, we'll talk about P1 and P2 and mu1 and mu2. Then in the alternative, it says test the claim at alpha is 0.05 that the average has not changed. It doesn't indicate whether it has increased or decreased. So what is the alternative? Not equal to. So mu does not equal to 65 is the alternative. Is everyone okay with those two parts so far? Which one is the claim? Yeah, so it says test the claim at alpha is 0.05, the average has not changed. Which one indicates the average hasn't changed? Yeah, and this one is the claim. I'm going to make sure it's the same way it's written on your homework. Which number is this? Yeah. Number 12. Yes, that's how it's written. Okay. Okay, making sure. Now, part 2, find the critical values and state your decision rule. What tailed test is this? Left-tailed, right-tailed, or two-tailed? Two-tailed, since the alternative is not equal to. That means if you draw out the distribution of the z-scores, your rejection region is going to be two areas. You're going to have the area to the left of some negative z alpha over 2. And what is the area to the left of that? It'll be half of alpha, because you want the area in these two critical regions to add up to alpha, right? So the area in each of them will be alpha over 2. So this would be 0.05 over 2, which is 0.025. And the area in this one over here would also be 0.025. What is this critical value, the critical values corresponding to that we talked about last chapter? What is the area in the middle? So 0.05, 1 minus that is what? 0.95. These critical values correspond to a 95% confidence interval for mu when we know sigma. Then, using that from last chapter, we look in the z table for area to the left of this and find the negative critical value. If you do that, you find it's negative 1.96. Then that implies the positive one here is equal to 1.96, not 1.99. Is everyone okay with that? Do you want me to show you how to find the positive critical value or not? The area to the left of this critical value should be what? If we want all the area from here over, that is found by 1 minus the area to the right, which is 1 minus 0.025, which is 0.975. If you look up that and find the associated z-score in the table, you will get the positive 1.96. I got a marker in my eye. Then, write the decision rule. So since it's two-tailed, we'll reject null hypothesis if the absolute value of our z-test statistic is greater than the positive critical value, greater than 1.96. Or you could say reject the null hypothesis. So here, say or. reject the null hypothesis if your z-test, so if the negative z-test is less than the negative critical value, so if it falls within this region here, is less than negative 1.96, or if your positive z-test statistic falls within that region up here, if z-test is greater than 1.96. These two things define the same exact rejection regions. What's another one you could have said since the p-value test? You could have also said reject null hypothesis if the p-value is less than or equal to alpha. And what is alpha in this case? 0.05. So that would be another way you could write the decision rule. On your exam, if I say use the critical value method, then I'm implying use this one. If I say use the p-value method, it implies this one. If I ask for both of them, if I ask you for the critical value and the p-value in the same problem, I will take either one. I don't care. Is everyone following up to there? Now, the third step is compute the test statistic. So just plug in the numbers we have up here. Then we have x bar was equal to 64. Mu naught was equal to 65. Sigma was 7. And n was 20. This gives you a test statistic to 2 decimal places of what? Yep, correct. Negative 0.64. How do you find the p-value? Whenever you have a two-tailed test, it's a little bit more difficult. By definition, the p-value is the probability of getting a sample statistic more extreme in the direction of the alternative. This is a two-tailed test, so you will have two areas that make up the p-value. What you want to look at is the area of the probability of getting an absolute value of z that is less than or equal to point. How do I want to do this? Yeah. Trying to figure out how I want to do this. Okay, I'm not going to write it that way, so we'll do this way. That means we're going to reject the null hypothesis if we get a z-test statistic that is less than this one. So this negative value here is going to define this left-hand rejection region, or the left-hand area. I hate explaining these two-tailed tests. Let's look at this. So here you have the distribution of the z-scores. Where's negative 0.64? So we have negative 0.64 is the test statistic we got, right? Then the area to the left of this, right here, is going to be only part of the p-value we want. We also want the probability of getting a test statistic greater than the positive one, 0.64. Oh, so I did have it right. So you want the probability of getting a z-test greater than the one you got, or the probability of getting this. The probability of getting a z-score in absolute value greater than z-test. That's what you want. That just means what's the probability of getting a z-score that is less than this negative one here or greater than the positive one here? What is the easiest way to find the area at both of those tails? So the table only gives you the area to the left, right? So look at this area to the left here. And do what to it? Multiply it by 2 because the area to the right is going to be the same. So then the p-value is equal to 2 times the probability of z being less than or equal to minus 0.64. In general, that's going to hold. So if I have a two-tailed test, I want to take 2 times the probability of z being less than the negative z test statistic. I know I confused you there. Yeah. Just think of it this way. Heck if I know. So this defines your left-hand rejection region, your left-hand area, right? The area to the left of that -1. Then this will define the right-hand area of it, and they're going to be equal because there are a number of standard deviations away from the mean on both sides. They're an equal number. Therefore, the area outside of each of them will be the same. Yes, multiply it by 2 to get both of them. Yeah, so you look at this one right here, and the z-score table and just multiply it by 2. That's the idea. For a two-tailed test, take 2 times the probability of z being less than the negative z test you get.
Okay, are we multiplying that number by 2 or are we multiplying its z?
The probability of it by 2. Yes. So look for this probability in the table. If you do that, holy cow, I didn't even, whoo, what is that divided by 2? Where's the exams? Who has the z-score table? Look up the area to the left of negative 0.64. Yeah, 0.2611. 2 times point, you said 2611? Okay. If you get that, you get a p-value of 0.5222, I think, yeah. Would you like to know how to do it on the calculator? Make it a lot easier. Let me switch the camera around. What you're going to do is go to stat. Go over to test. So in this case, we're just doing one sample test. So hit z test. So this will do a 1 sample z test for the mean. So it's saying whether you input data or statistics. If it gives you a number, like a list of numbers, like on some of your homework problems, it will, then you'll have to put those numbers into the calculator into one list and then the other. That's in this case, just one list. If it gives you statistics, like it says the mean is this, the hypothesized mean is this, then you enter in statistics. In this case, I just tell you statistics. Then it'll say, what does the hypothesized mean? In this case, the hypothesized mean was 65, right? What is the standard deviation? The population standard deviation was 7. What does the sample mean? It was 64. And what is n? 20. And then I'll say, what is the alternative hypothesis? Is it not equals to, less than, or greater than? It's not equals to in this case. Go down to calculate. It tells you the corresponding z-test statistic, the p-value. It tells you everything you need to know. The only thing it doesn't tell you is the critical values. So you need to know how to find those. So if this way of doing it by hand kind of confuses you on a two-tailed test, you can plug into the calculator. Yes. Go into stat, over to test. So we're just doing z-test now for when we know sigma. Whenever we don't know sigma in the next section, we'll use t. But for this section, just use z. Hit that. Go over to stats at the top. select that. Then go down to where it says mu naught, and that's just the hypothesized mean under the null hypothesis. So in that case, we have mu is equal to 65 as the null. So 65 is mu naught. Then tell it the population standard deviation, which is 7. Tell it the sample mean, which is 64. Then the sample size, which is 20. And then the alternative. I don't know on an 83 if it has this last step or not, the alternative. I have no idea. I will have to look when I get back to my office. And then once you have all that selected, hit calculate. Oops, gosh dang it. And you'll get whatever I just got a second ago. Gosh dang it, I did it again. See, then just go down there after you entered all that in, then hit enter, and it will tell you all that. Does that help, Olivia? Did I go too fast? Okay, then based on that p-value, what is your decision? Okay, cool. Is that p-value greater than alpha? Yes. Therefore, you fail to reject the null hypothesis, and you say there is sufficient evidence to conclude the alternative, which is the average acreage has changed. Is everyone okay with that example too? Then I guess we'll give a little brief what we're going to talk about next time. Just like last chapter, how we talked about a confidence interval when you knew sigma and when you didn't. In this case, you'll do a hypothesis test when you know sigma and when you don't. It'll be kind of the same idea as before. Can you flip back over real quick? Yes, I can. There. I just may have erased some of the stuff you need. Then I would probably get started on your homework because it's going to be kind of tedious. Should I tell you something real quick before y'all leave or not? Yes. Okay. Your homework is very weird on the last part of some of the questions. Which one is this? Question 11. I'm going to flip it back over. Okay. It will say summarize your results and click one of these decisions. It says there is blank that drivers over 60 years old drive less than 24 hours per day on average. This part is kind of a pain. It says not enough evidence to support the claim, not enough evidence to support the claim, or not enough evidence to support the claim, enough evidence to support the claim, not enough evidence to reject the claim, not enough evidence, or enough evidence to reject the claim. Whenever it says to support the claim, that indicates that the claim is the what? Alternative. Whenever it says reject the claim, then it's the null. I will get some questions guaranteed over it. I hate the way it's worded. So on your exam, do you think I word it that way? No, not that mean. It'll say something like, what's your decision and do you support the alternative? That's the way it's written on an exam. Your homework is a pain in the butt with this. So I thought I'd mention that now. All right, y'all are good to go. You too. Bailey, what's up?
Okay, wait, can you hear me?
Yes, I can.
Okay. So this is not a very smart question, but I'm finishing the chapter 7 homework for tonight.
Yes.
I even looked it up on Google. Maybe I'm just doing it wrong in the calculator, but I cannot, this is so simple, but the standard deviation, I cannot figure it out.
Okay.
It's when it's not given to me.
Does it give you like numbers?
Yeah,
Yeah, you can just find the standard deviation on, like, look up a standard deviation calculator on Google and you can find it. Or you can enter
okay,
a calculator and actually find it that way too.
okay. Because I looked up an example and I was like, all right, still got the wrong answer, but I'm gonna look up a calculator online.
All
Thank
right.
you.
You're welcome. Yes, you can.